Okay, so this is example number 5 from Related Rates Day 2. This is one of my favorite examples, not so much for the students, but one of my favorites. So we have a camera, and the camera is mounted about 3,000 feet from the base of a rocket, and the rocket is rising vertically, and the rocket is rising at 850 feet per second. So therefore, that would be dH dt. And when the rocket is about 4,000 feet above the launching pad, so that would make h about 4,000, we want to know how fast this angle is changing. Okay, so this is a different formula that we're going to have to use. So what is the formula that can relate the angle to this? Now, if we go back to trig ratios, we could use either of the trig ratios. We could use sine, cosine, or tangent. I am going to choose to use tangent. And the reason that I'm choosing to use tangent is because I have dH dt, okay? If I were to use sine or cosine, if I were to use, let's say, sine, which would be h over the hypotenuse, both h and the hypotenuse are changing, so then I would need to know the rate at which this hypotenuse is changing, and I don't know that. The reason I really can't use cosine theta, because cosine, there's no relationship between cosine and this angle and dH dt. So if I were to use cosine, I would have 3,000 divided by the hypotenuse, and the hypotenuse is changing, so once again I would have to know the rate at which that is changing. So taking all of that into consideration, I think it's better to use tangent. So we know that tangent of theta is equal to the opposite side, which in this case is h, over the adjacent side. Now, the adjacent side is a constant. This distance between the camera and the rocket is not changing. So this 3,000 is a constant. Okay? The 4,000 is not a constant because this is changing. As the rocket lifts off, that 4,000 changes every second. But this 3,000 is not changing. So this is going to give me the derivative of tangent theta, if you recall, is secant squared theta. Using chain rule, that will give me d theta dt, is equal to, well, this is like, we can write this as 1 over 3,000 h. This is a constant. So this constant remains the same, and then we multiply by dH dt when we take the derivative. Okay? Now, the other thing we need to remember is this, that secant squared can be written as cosine, 1 over cosine. So I can rewrite this as d theta dt over cosine squared theta, and that's equal to dH dt over 3,000. Okay? So what we're trying to find is d theta dt when h is 4,000. Okay? So then this gives me d theta dt is equal to dH dt, which I have is 880, divided by 3,000 times, I can write this as cosine squared theta. Alrighty. So to find d theta dt, all I need now is cosine squared theta. Well, what do I know about cosine? I know that cosine is the adjacent side over the hypotenuse. And so if I can find cosine theta, I can substitute that value in. So this is a, recall from geometry, this is a 3, 4, 5 triangle. So when this is always 3,000. When this is 4,000, this hypotenuse is 5,000. So therefore, cosine of theta is 3,000 over 5,000 which simplifies to 3/5. So cosine theta is 3/5. I don't need to know the exact value of theta. I just need to know what cosine theta is, and cosine theta is 3/5. So I'm just going to insert this information to find d theta dt. So d theta dt is equal to dh dt, we know, is 880. We know that this is 3,000 times cosine theta, which we now know to be 3/5 squared. And I do not have, this is 3,000, a calculator, so I'm going to simplify this as best as I can. This 0 and this 0 will cancel each other out. This 3 and this 3 will cancel each other out. So I think what I'm going to be left with is 880 times 3/1,000 times 25. And I'm sure you can tell me what that value is. And this is d theta dt. And what would be the units for this? The units for this would be radian per second. Okay? And that is the answer. So that's it for the related rate section. Your homework assignment is not listed in your notes, but you want to complete 34 in your notes. And then you want to do practice worksheet on the website. So if you go to the website, there should be a practice worksheet. So you want to do page 34 in your notes, the practice worksheet on the website, and the answers for both of those are on the website. So I will talk with you later.